In this video, we'll talk about example number 2, but like I mentioned at the end of the last video, be sure that you try this example on your own. You want to make sure that you're understanding the concepts so that if you're ever asked to do a question like this in the future, you can feel a little bit more comfortable that you've already kind of seen and worked through a problem on your own. So if you haven't gone ahead and done that already, make sure you pause this video before going any further, give it a shot, and then unpause the video to see me work through the solution. All right, well, here's what you should have gotten. If I'm first starting by sketching out the region that I have, I can see here that my region is going to look like the following. I'm going to have my square root function existing over here. Y equals 0 is my x-axis, and I have x equals 4, which is a nice vertical line going up through here. So I'm just providing a real quick rough sketch of what I have. So the region that's kind of fenced in by these curves is going to be this space in here. All right, so this is the space that I'm working with. And so we want to go ahead and determine the area of this space in order to start to try to find where that center of mass is going to be. So I'm going to go ahead and actually calculate the area up here just because I have some extra space in order to be able to do it. Now, calculating my area here is going to be much easier to do with calculus than with geometry because this region here is not a nice geometrical shape. So I'm going to go ahead and say that I'm integrating from 0 to 4 the function of the square root dx. And so to integrate this, I'll go ahead and quickly just think about rewriting this as x to the 1/2 power, and then finding my antiderivative is pretty simple. This is going to be x to the 3/2 power times the 2/3 out front, and I integrate from 0 to 4. Now when I plug 0 into this, I'm clearly going to get 0, so my answer is just going to actually look like a 2/3 multiplied by 4 to the 3/2 power. Now you may have stopped here, but you can actually simplify this down a bit further. Remember that when you have a number to a fractional power, you can take it or think about that power there as being like a 3 times a 1/2, and so you can apply those powers in any order you wish. So I'm going to go ahead here and think about first applying the power of a 1/2 to my value of 4. So notice that's going to be 4 to the 1/2 power is 2, 2 to the 3rd power is 8. And so this is going to be the same as 2/3 times 8, or the same as 16/3. That's my area of the region. Now again, that's not a part of doing part A here. I just wrote it there so I can save a little bit on space for part B. Now to find my actual center of gravity, I'm going to compute those two integrals. First one being my x bar integral. So remember, this is going to be 1 over the area, or the reciprocal of the area fraction that I got. And then I'm going to be integrating from 0 to 4, and it's going to be x times square root x. Now again, I'm going to do a little bit of algebra here to simplify this up before I attempt to integrate. I'm going to rewrite this as x to the power of 3/2 and then continue to integrate. Please be careful. You can't integrate each one of these separately. You can't write this as like 1/2 x squared and then write the other one as x to the 3/2 times the 2/3. This does not work. I can't integrate each piece in a product. That's not how I would do an antiderivative. So be careful of that if that's the route you were leaning towards. I can do this algebra move to combine these, and then everything here is pretty straightforward. My power is going to go up to a 5/2, which means I'm going to have a 2/5 in front. Now I'm going to go ahead and evaluate this from 0 to 4, and I can see that that's going to get me, I'll move this down to my next line. This is going to get me 3/16 multiplied by this 2/5 times 4 to the 5/2 power. And just like we saw up above with the area calculation, I can calculate 4 to the 5/2 power by first doing 4 to the 1/2 power, which is 2, and then 2 to the 5th power, which is 32. So this is going to be 3/16 times 2/5 times 32. So I should be able to go here and compute this pretty easily now and simplify everything out that I need. First off, I can go ahead here and see that I'm going to end up with 3/16 times 64 over 5. And that's going to go ahead and ultimately reduce down, let's see, the 16 and the 4. Those will simplify out, leaving me with the 4 up top. And so I'm going to end up here with a grand total of 12 fifths. So 12 fifths, or that would be the same as what, 2 and 2 fifths, or that's the same as 2.4. So just in case you're kind of wondering where exactly 12 fifths would be located, that's the same as the value of 2.4, and I can kind of go ahead over here and imagine where that would be plotted. So if this is where 2 is, and this is where 3 is, this is where 1 is, I can kind of imagine, all right, 2.4, I'm going to be sitting, somewhere over like here, roughly. And then I'm going somewhere up in this space is where my center of gravity is going to be. Well, now I can go ahead and compute my y-bar. My y-bar, again, is going to still have that 1 over the area, or a reciprocal of that area fraction, an integral from 0 to 4. And then I'm going to have a 1/2 times my function of the square root being squared. So again, this here is really easy. I'll take my 1/2, pull it out to the front first. I'm going to get a 3 over a 32. I'm going to have an integral of 0 to 4, and this is actually just going to be of x, because after I square root the radical, that's what I end up with. So I'm going to have 3 over 32 times a 1/2 x squared, and evaluate from 0 to 4. I'm going to go ahead and combine my 1/2 again right away. I'm going to have a 3 over a 64, and then I'm just going to have a 4 to the 3rd power. Of course, when I plug in 0, I don't get anything from that. So let's see, 4 to the 3rd power. Oh, sorry, not to the 3rd power. I was wondering if that looked a bit off. It should be to the 2nd power, my apologies. But that's going to produce, let's see, 3 times a 16 over a 64. And again, 16 divided by 64, that's going to create a 4th. And so here I should end up with a value of 3 over 4, which of course I know is 0.75. Okay? So it doesn't really matter how I choose to express it. Whether in the decimal or in the fraction form, either is appropriate, but I can go ahead then and write down where my center of mass is located. So I have my center of mass. My center of mass is going to be located at 12 fifths, 3/4. And again, I should be able to go ahead and see that this makes intuitive sense. This is important. You want to make sure that your answer makes intuitive sense, so that way you can check to see if what you have is even a reasonable answer. Notice here that if I'm going to take a look at the y-coordinates, it might be helpful to note that over here at 4, my region goes up to a height of 2, so I have a sense of where 1 is. And so if I go up to maybe a height of 0.75, I could then see that we're saying that maybe right around here is the center of mass, the perfect balance point for the region. And I think it should be pretty easy to go ahead and determine in most cases where the center of mass is roughly, right? That is, I could probably have easily guessed right from the beginning that right here was not the center of mass, because I could imagine if I had, again, this yellow region cut out in a piece of paper, and I tried to balance it, say, on my finger right underneath that blue point, there's no way this would balance on my finger there. So it's pretty easy to maybe, if I had several points to choose from, and I said which of these is probably going to be the center of mass, even without knowing the points, you could probably select the one that's going to fit here the best. Hopefully you were able to get this particular answer, and if not, hopefully seeing my solutions made things a bit more understandable. And if you have any lingering questions, by all means, please let me know.